In this video, we are going to take a look at adding, subtracting, distributing, and FOILing radicals. Very similar to what we did last time, you had a chance to do a lot of different simplifying techniques, so we will still be simplifying. And notice the directions are the same, still, oops, undo, I just had the eraser on by accident. We are still simplifying as our directions, assuming all variables are positive, because again, that helps us with avoiding some extra absolute value stuff that we'd have to do with the variables. Once we are at this point, when we have our first example here, 3 square root of 5 plus 8 square root of 5, this is very similar to simplifying the expression 3x plus 8x. Notice in purple, I have the square root of 5 and the x. So my question to you is, how would I combine 3x plus 8x? Hopefully the answer that you would give to me would be to combine the numbers in front to get 11, but leave the variable the same. So it would be 11x would be my answer for that. And you would call that combining like terms. Combining like terms is really the same thing as what we're going to be doing here. We're going to combine like radicals instead. And radicals are technically terms also, but we're looking for the same radical in order to be able to combine it. So in this example, square root of 5 and square root of 5 are the same. So we would combine it the same way, combine the numbers in front, and then put the square root with our answer. So you're not changing the square root. The reason you can combine them is because they both have the square root 5. Let's do a second example like that before we get into simplifying first. We're going to do 2 cube root of 3x squared minus 3 cube root of 5x plus 7 cube root of 3x squared. Now we're looking for like terms. So I notice this is a cube root of 3x squared. I have another cube root of 3x squared here. So we'll be able to combine those. Unfortunately, this is a cube root of 5x, so that's a different term. So we won't be able to combine that. And then for this, when I combine the numbers in front, make sure you include the sign in front with it. 2 plus 7 is 9, so I'll get 9 cube root of 3x squared. And then since I can't combine the other one, I'll just rewrite it as 3 cube root of 5x. And that would be my final answer for that example. I haven't done any simplifying yet, but we will do that in the next example. I'm cutting this example down a tiny bit from the one that's posted in the notes. You will have a bunch of simplifying to do here, so I would spread this out decently in the horizontal direction, because now I have no like terms, but I do have radicals that I can simplify. So I'm going to simplify each of these. I'm going to do one at a time, and you can do it how, what works comfortable for you. I'm going to use factor trees, although you were given 2 techniques that you could use from the previous lesson. So go with the technique that you're comfortable with when you're doing practice. I'm going to split this first one into 8 and 10, and then we'll do 4 and 2, 2 and 5, 2 and 2. I'll circle up all my prime numbers. And then be very careful to bring down the number in front, especially because there's a lot going on in this one problem. So I have 4 2's. And remember, for a square root, we're circling groups of 2, and we're going to take out one of each of those groups if you're using this technique. So I will have 2 times 2 times 2, and then the square root of 5 will stay on the inside. Just slide that up a little bit. So that term will be 8 square root 5. Now I have to do that 2 more times. So go to the next one. Square root of 40, I will simplify. I did 4 and 12, you can do 6 and 8. No matter how you break up your factor tree, everybody should get to the same final result. So you can already tell this one's a little different than the first one, because instead of a 5, I have a 3 left. Again, don't forget to bring down the minus 3. That's why it's good to spread these out to keep them organized. I have 4 2's and 1 3. And we're in square roots, so I'm circling groups of 2. So this one's a little similar to the previous one because I have 2 groups of 2 that I'm bringing out, but the inside is different. Remember, you're only bringing out 1 from each group if you're using this technique. And then if we multiply this out, we get minus 12 square root 3. So far, I actually don't have any like terms, so hopefully when I do this last one, I'll have a like term that I can combine. This one, I always like to use the 0 and split it into 10 times something, but again, doesn't really matter how you split this up. Circle up all my prime numbers and bring down the plus 5. So I notice I have 2 2s, 2 3s, and a 5. Circle up my pairs. Now I'm bringing out 2 different numbers. I'm bringing out 1 2 and 1 3, but I do have a square root 5 left on the inside, which is good because there's another spot where I had the square root of 5. And then if you multiply this out, we will get 30 square root of 5 for that term. Now, if I'm looking to combine like terms, I'm only going to combine the ones with the square root of 5, and I'll leave the one with the square root of 3 alone. So that will give me 38 square root 5 minus 12 square root 3. And the example in the notes, the posted notes, I had 1 extra term in here, which would just mean another simplifying and then a little bit extra with the combining. But I think since we've done a lot of work with simplifying, doing 3 in this problem was plenty. I'm going to do one more with the adding, subtracting. This will be the last one for this video because the second video will talk about the foiling and the distributing. So we're going to do 5 fifth root of 2y to the 5th. So I'm going to add a variable into this one, minus y fifth root of 64. The first one, I can take out the variable. The y to the 5th would come out because that's really like 5 y's if I were to write that out. So I'll bring that to the outside. It'll be 5y fifth root of 2. And on the next one, I already have the y in front. I'm going to hold off to see what will come out from this. So I'm going to do my factor tree. We can do 8 and 8, 4 and 2, and you'll notice that you get 6 2's. I actually probably should have brought that other one down a little bit further, but we can make that happen. So it'll be minus y fifth root of, I'm going to write 2 to the 5th times 2 instead of writing out the 6 2's. There's an alternative way to do it just to make it a little bit less writing. So I know I'm going to be bringing that to the outside. I'm going to bring down this 5y fifth root of 2 minus, and then it will be 2 in front of the y fifth root of 2. So what you want to look at, this one has a variable and a radical, but it's exactly the same. Y fifth root of 2, y fifth root of 2, so that allows me to combine the numbers in front to get 3y and tack on that fifth root of 2 for your final answer. So that concludes this video. You'll check out the second video, again, like I said before, to do the distributing and the foiling.